Hello everyone, my name is Rachel Kanguha. I'm a pediatrician from Kenya.
And my name is Dr. Frederick Mutisya. I'm a medical doctor and a data scientist from Kenya. Our solution is antimicro.ai. It's an artificial intelligence web app that helps predict antibacterial and antifungal susceptibility and builds custom machine learning models. So as we all know, drug resistance is an emerging problem, also in the global south. We have clinical decisions that are not supported by current evidence, and this can lead to inappropriate use of certain antibiotics while ignoring others which are still effective. Also, there is an inherent lag between culturing an organism and doing resistance testing, which can lead to the reflex use of inappropriate antibiotics. And that's where our solution comes in, antimicro.ai. We are very intentional that all the software we've used for our solution is free and open sourced to ease adoption and customization by other researchers. We did some exploratory analysis. Above is what we had in our data sets. We had a threshold of 50% for missing data. So we used 15 different machine learning models, and we settled on extreme gradient boosting because it was the most resilient model in terms of missing data and outliers. And also it had the highest area under the curve, accuracy, recall, and precision. So what are the implications of antimicro.ai? We see it as a client-centered tool that can improve patient outcomes, reduce the time to optimal antibiotic therapy, and reduce client hospital stay and cost. At the macro level, we see it as a policy development tool that can inform antimicrobial resistance policies at the hospital, regional, and national levels. So this is the homepage of our app. It's antimicro.ai. On the left-hand side, we have the instructions. On the bar on the top, we have the different functionalities. We have the home, we have about the Pfizer dataset, and we have subgroup analysis, which I've presented before, which I'll not delve into because of time. Allow me to go to the antibacterial predictor and demo it for you. So we have instructions on the left panel. Then in the main tab, we have the different predictive variables. We have the suspected bacterial species. Here we have 300 bacterial species, which were in the Pfizer Atlas dataset for antibiotics. Allow me to choose Acinetobacter baumannii since it's a WHO critical organism. You can change the country, the specialty, the source of the sample, the year the sample was taken, the phenotype, and the antibiotic. Let's change the antibiotic to, let's say, ampicillin sulbactam. You click on the model result, and it will say that there is a high probability that the organism is resistant to the antibiotic chosen. And we've accompanied a disclaimer on the limitations of any predictive AI model to follow the result that is given. That's the first functionality. The second functionality is the same antibacterial predictor, but now with the genotypic data. It has the same drop-down menus for bacteria, country, specialty, the sample source, the year, and we've added the 22 different genotypes that were present in our dataset, such as OXA and the rest. These genotypes were based on the beta-lactamases. The last functionality is the antifungal predictor. Here, let me change this to Candida albicans, and let me change the antibiotic to fluconazole. And it shows that there's a high probability that the organism is susceptible to the antifungal chosen.